The biggest mistake we made when looking for aliens wasn't looking in the wrong places. It was fundamentally misunderstanding what it takes to build a civilization. We've always assumed that if a planet has liquid water and biological life, it will eventually build rockets and radio telescopes. With billions of Earth-like planets in our galaxy alone, the math says we should be surrounded by other civilizations. That is the Fermi Paradox, the lack of signals in a universe that should be full of life. For decades, this silence worried us. We thought it meant intelligence was a rare accident and that humanity was entirely alone. But recent breakthroughs in astrobiology have changed this view. Scientists now believe the universe is full of life. However, most of that life is facing a problem we never considered. It turns out, evolving a highly intelligent brain isn't the hardest part of exploring space. The real barrier is a hidden physical obstacle that Earth somehow avoided, but other planets likely did not. We finally have a working solution to the Fermi Paradox. It guarantees that alien life is out there right now, but they are all dealing with a massive problem that keeps them completely hidden from us. To understand why the universe is so quiet, we just need to look at our own cosmic backyard. 4 billion years ago, our solar system had 3 planets that were practically identical twins: Venus, Earth, and Mars. All 3 were rocky. All 3 likely had liquid water on their surfaces. All 3 possessed the exact chemical ingredients necessary to spark biological life. If you looked at them back then, you would have assumed all 3 were destined to become bustling, living worlds. So, what happened? Why is Earth the only one with a civilization today? The answer lies in how incredibly violent young planets actually are. When a new world forms, it does not naturally settle into a peaceful, stable climate. It is chaotic. Greenhouse gases fluctuate wildly. Temperatures swing from deep freezes to boiling heat. For a young, rocky planet, stability is not the default state. Rapid, deadly climate change is. Astrobiologists now realize that when simple life, like basic single-celled microbes, sparks on a young world, it is immediately thrown into a desperate race against time. These microscopic life forms have to evolve fast enough to actively regulate the planet's atmosphere before the chaotic climate destroys them. Scientists call this brutal physical barrier the Gaian bottleneck. Think of a young planet as a wild, unstable engine. If early biology cannot figure out how to regulate the temperature quickly, the engine violently breaks down. On Venus, the atmosphere rapidly thickened into a runaway greenhouse effect, boiling away the surface water and baking any potential early life into dust. On Mars, the planet's core cooled. The magnetic field collapsed, the atmosphere was stripped away by solar winds, and the surface froze solid. Any basic life that might have existed on Venus or Mars simply did not evolve fast enough to stabilize their environments. They lost the race against their own planets. This reveals a harsh reality about our cosmos. The universe is likely incredibly efficient at creating basic microscopic life. But the vast majority of that life goes extinct almost immediately because it fails to stabilize its host planet's rapidly changing climate. The galaxy isn't empty, it is likely a massive graveyard of single-celled failures. Earth, however, pulled off an absolute miracle. Our early microbes did something extraordinary that saved our world from becoming a dead rock. They physically hijacked the planet's atmosphere. And understanding how they did it is the only way to understand why we survived. The planetary graveyard theory explains why simple life fails, but it doesn't explain the silence of the worlds that actually survived. If a planet manages to stabilize its climate and allow life to evolve for billions of years, we should see the results. This brings us to a second, more mechanical solution to the Fermi Paradox, the water world trap. When we look at Earth, we see a perfect balance of deep oceans and massive continents. This setup allowed us to discover fire, which led to smelting metal, which eventually led to building combustion engines and rockets. But according to recent computer models of planetary formation, Earth is a geological oddity. Most habitable planets in the galaxy are likely ocean worlds, planets covered by a single global ocean miles deep with no land in sight. Imagine an incredibly intelligent alien species evolving in these oceans. They could develop complex languages, intricate social structures, and advanced mathematics. But without dry land, they can never discover fire. Without fire, they can never forge metal. They are physically locked into a Stone Age level of technology. Not because they lack the brains, but because their environment makes high-tech manufacturing impossible. They could be the most brilliant philosophers in the galaxy, but they will never build a radio transmitter under 1,000 miles of water. This creates a universe that is full of life, but fundamentally dark. These civilizations aren't missing because they are dead. They are missing because they are technologically stranded. They are looking up at their watery ceilings, unaware that a vacuum even exists above them. However, even this doesn't cover every possibility. What about the planets that do have land? What about the civilizations that successfully build the rockets and the telescopes we've been looking for? Scientists have proposed a third, much more unsettling theory that suggests even the most advanced societies eventually reach a point where they simply stop wanting to be found.
This unsettling possibility is known as the Great Filter of the Digital Age, or the inward turn. As a civilization becomes more advanced, its technology doesn't necessarily move outward toward the stars. It moves inward toward a simulated reality. Think about the direction of our own progress. We are currently spending billions of dollars to develop virtual worlds that are increasingly indistinguishable from the real thing. To a sufficiently advanced society, the physical universe is a cold, empty, and dangerous place. Traveling to a distant star takes centuries and carries the risk of total destruction. But a digital world can be a perfect paradise. It is infinitely customizable, completely safe, and requires only a fraction of the energy needed to launch a single rocket. Scientists suggest that once a civilization masters advanced computing, they might choose to upload their consciousness into massive, planet-sized supercomputers. Instead of spending thousands of years colonizing a dead galaxy, they live out millions of years of subjective time in a few seconds of real time, experiencing every pleasure imaginable within a digital simulation. These virtual civilizations wouldn't emit radio signals or build massive steel structures. From the outside, their home planet would look like a quiet, dark, and boring rock. This would explain the Fermi Paradox perfectly. The universe isn't empty. It's just that everyone who reaches our level of technology realizes that the real world is a waste of time. They have essentially retired into a digital heaven, leaving the rest of the galaxy behind. But there is a darker side to this transition. If a society turns inward and stops expanding, they become incredibly vulnerable. A civilization that lives only in a computer can be wiped out by a single asteroid or a dying sun because they've stopped looking up. This suggests that the silence we hear might be the sound of civilizations that reached their peak and then simply forgot the rest of the universe existed. It raises a terrifying question. Is this inward turn a choice, or is it an inevitable trap that every intelligent species eventually falls into? If this theory is correct, then the very technology we are building today to make our lives easier might be the very thing that ensures we never meet another living soul among the stars. But even this assumes that civilizations survive long enough to build these computers, which leads us to a much more physical, unavoidable problem. The physical reality of the universe suggests that even if a civilization avoids the digital trap, they may hit a wall built by the laws of physics themselves. This is the theory of the Percolation Threshold. Space is not just big, it is hostile and incredibly difficult to cross. We often imagine a galactic empire spreading like a wildfire across the stars, but science suggests it may function more like water, trying to flow through a pile of dry sand. In this model, the stars are the grains of sand. For a civilization to expand, it needs a nearby star system that is not only habitable, but also reachable with the energy they have available. If the distance between useful stars is too great, the civilization becomes a lonely island. They might colonize one or two neighbors, but eventually they hit a gap they simply cannot bridge. Because the universe is constantly expanding, these gaps are getting wider every second. This leads to a patchy universe. Instead of one giant connected galactic community, you end up with tiny, isolated pockets of life that never meet. From our perspective on Earth, we might just be sitting in one of the empty patches. We are like a person standing in the middle of a vast desert, concluding the world is uninhabited because we can't see the next oasis over the horizon. The civilizations aren't missing. They are just too far apart to ever see each other's campfires. But there is a more sobering version of this physical limit. Some scientists believe that advanced civilizations eventually realize that interstellar travel is a bad investment. The amount of energy required to send a ship to another star is enough to power an entire planet for centuries. A rational society might decide that it is better to use those resources to perfect their own world rather than wasting them on a cold, empty void. This brings us to the final, and perhaps most verifiable solution to the Fermi Paradox. It isn't about where the aliens are, but rather when they are. We assume that because the universe is old, civilizations should be everywhere right now. But the latest data on star formation suggests that we might have arrived at the party much earlier than anyone else. While the universe is 13.8 billion years old, the ingredients for life, heavy metals and stable solar systems, have only been abundant for a fraction of that time. It is entirely possible that we are the firstborn. If this is true, the reason we haven't heard from anyone else is that the others haven't even evolved yet. We aren't looking at a cemetery, we are looking at an empty nursery. However, being the first comes with a terrifying responsibility that most people have never considered. The physical hurdles we've explored, from the climate traps of young planets to the gravitational prisons of super-Earths, lead us to the most verifiable solutions scientists have today: the early bird hypothesis. While 13.8 billion years seems like a long time, in the life cycle of the entire universe, we are actually living in the very beginning. Data from the Hubble and James Webb telescopes suggests that when our solar system formed 4.6 billion years ago, only 8% of the potentially habitable planets that the universe will ever produce had been born. This means that 92% of Earth-like worlds haven't even formed yet. They are still just clouds of gas and dust waiting for their stars to ignite. This provides a direct, measurable answer to the Fermi Paradox. We haven't heard from anyone else because we have arrived at the party before most of the guests have even been born. The ingredients for life, heavy metals forged in the hearts of dying stars, needed billions of years to build up in the galaxy before complex life could even be possible. We are effectively the first generation of intelligence. If we were to look out at the galaxy and see it teeming with life, that would actually be the scientific anomaly. By understanding this, the silence of space stops being a mystery and starts being a timeline. We aren't looking at a graveyard, we are looking at an empty nursery. For decades, the Fermi Paradox felt like a dark omen, suggesting that all intelligent life is doomed to fail. But the latest science offers a more grounded perspective. The silence of the universe isn't a message of destruction, it is a reflection of how difficult and rare it is to reach this exact moment in time. We are the survivors of a brutal cosmic lottery. We emerged on a planet that stabilized its climate, we evolved on a world that wasn't trapped underwater, and we appeared at a time when the universe was finally ready for life. If we are the only ones currently capable of looking at the stars and wondering, where is everybody, then we are the ones responsible for the answer. The universe isn't empty because it's a graveyard, it's empty because it's waiting. We aren't the audience of a cosmic play, we are the opening act. And for the first time in history, the stage is ours.